assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So, in metal complexes, we know that the central metal atom or ion is generally a transition metal which has 5 d orbitals, and these d orbitals, in case of a ground state or in case of a single atom or ion, these d orbitals are degenerate. That means they have the same energy, all of these 5 d orbitals. But when a ligand approaches this d orbital while forming a complex, due to the repulsion between the electrons from this d orbital of the central metal atom and the electrons from the ligand, due to that repulsion, uh, these degenerate d orbitals get splitted into two different energy levels. So the higher energy levels, here we have two or three on the higher energy level based on the molecular geometry of the compound, and we will have the others in a lower energy level based on the molecular geometry of the compound. So this splitting is for octahedral um, octahedral m- metal complexes. So, and for the tetrahedral metal complexes, we will have a splitting like this: um, three on top and two on bottom. So now, so based on this, we can see that since we have two different types of orbitals in two different energy levels, what happens then? So then, when the electrons from the ligands come and they actually occupy these d orbitals uh, like this, or they can first fill up the lower energy level orbitals by pairing up, and then they can go to the higher energy level. So whether they will first go to one at a time in each orbital, or whether they will first fill up the uh, lower energy level and then go to the upper one, this actually depends on the uh, electric field strength of the ligand. So if the ligand is of a strong field, it will cause a higher energy difference between um, the lower energy level orbitals and the higher energy level orbitals. So the difference of energy between these two will be very high if the ligand is strong field. So, and what will happen in that case? So since um, the ligand is strong field and the energy difference between these two is very high, in that case the electrons from the ligand will not be able to go to the higher state, or they will need very much higher energy to go to the higher level orbitals. So what will happen in that case? In that case, they will first uh, fill up the lower um, energy level orbitals. Let's go to another page here, and if we just draw our um, orbital splitting one more time like this. So if the ligand is a strong field, then the difference between these two energy level is very high. And for this high difference, so the electrons will first occupy the lower energy level first, one at a time, and then they will pair up. So that means that if the ligand is of strong field, we will have a minimum number of unpaired electrons. That means that the most of the electrons will be paired. And for this minimum number of unpaired electrons, as we know that the paired electrons are actually have neutralized spin, so there will be a very low amount of spin, and that's why these these complexes which contains strong field ligands, they have they are called low spin complex. And on the other hand, if the orbital splitting is like this, and so if the ligand is a weak field ligand, in that case, this the difference between these energy levels will not be that high, and in that case the electrons from the ligand will be able to go to the upper level also. So what will happen in that case? So the electrons will first occupy one at a time the lower energy levels, and then they will also occupy the higher energy level orbital, and if there is more electrons, they will pair up. So in this case, we have the possibility of having maximum unpaired electrons. So if we have um, if we have weak field ligand, if we have weak field ligand, that means that we will have maximum number of unpaired electrons, and that will result in a high spin complex. So how can we know that whether a complex is low spin or high spin? So that's very simple. We just need to know whether the ligand in the complex is weak field or strong field. And there is a chart which is called a spectrochemical series, where the most common ligands are arranged in an order of weak to strong ligands. So in the top line, the green marked ligands, these are our weak ligands, and the bottom ones are in red mark, these are our strong field ligands. So for example, if we have an complex of CO H2O6 um, 3 plus, that means that this H2O is here. That means that this is a weak field ligand, and since the ligand is weak field, the complex will be high spin. And let's take another example of nickel cyanide, nickel tetracyanide, where the nickel is cyanide, and since it is a strong field ligand, that means that this complex is a